Okay guys, so we are starting 2.6 part 1. This has to do with related rates. We are taking the derivative with respect to time. Okay, so listen up. So we've been taking the derivative with respect to x. When we take the derivative with respect to x, then that means that we're finding the rate of change of the y value with respect to that change in the x. That's finding slope. But now we're going to be looking at finding the rate of change of y with respect to time and the rate of change of x with respect to time. So what that means is this. Let's say we throw an object like this, let's say the football game last night. So they throw a football, it goes in this kind of pattern. So when I'm looking at the change in x with respect to time, that means this horizontal distance with respect to time. When we talk about the change in y with respect to time, that means how fast is that ball rising or falling with respect to time. Okay, so those are the types of things we're looking at today. So first we're just starting off with some basic equations. We have y equals 4 radical x. You should know what that function looks like. A radical x function just looks like this. If it's times 4, it's just a vertical stretch by 4, so it's going to look like that. So if I'm trying to find dy dt when x equals 9, given that dx dt is 8, we're just going to take our derivative with respect to time. So the derivative of y with respect to time is just 1 dy dt. This is really 4x to the 1/2. So this derivative, 4 times a half, is 2x to the negative 1/2. And then I have to put dx dt because I'm taking the derivative with respect to time. Now it's just a plug and chug type of thing. I'm trying to solve for dy dt. This would be 2 over radical x dx dt. I know what dx dt is. It's 8. So I plug in 8 for dx dt. We plug in 9 for x. And so this is going to be 3. So we're going to have 2 times 8 is 16/3. So that's telling us that when the x is changing at a rate, or the horizontal, if you want to think of it that way, is changing at a rate of 8, the y is changing at a rate of 16/3 with respect to time. All right, so what about if we have to find dx dt, given that x is 16 and dy dt is 9? Well, I'm going to take my derivative function right here. I'm just going to substitute in 9 for dy dt. X we don't know, or x we do know rather, it's 16. dx dt is what we're solving for. So simplifying this, I'm going to have 9 equals, this is going to be 2/4, which is 1/2, multiply by 2, and so dx dt is 18. So what that tells us then is that when y is changing at a rate of 9, x is changing at a rate of 18. If this dy dt is positive, it means it's going up. If the dy dt had been negative, it's going down. So the only way to make dy dt negative is if we're traveling in this direction. And then what would dx dt be if dy dt is negative? If I'm making dy dt negative, which direction am I going for x? Negative. So in this problem, when dx dt is positive, so is dy dt. When dx dt is negative, so is dy dt. All right, let's go over to the back now. A point is moving along the graph of the function such that dx dt is 3 centimeters per second. Find the rate of change in y with respect to time for the specified values of x. Here's our function, y equals cotangent x. I like you to know what these functions look like. Cotangent, whenever I have that O there, my asymptote is at x equals 0, x equals pi. That's how I remember it. Then I want to know, is this one going up or down? When this is an O, it's going down. Cotangent is going down like this, decreasing. Tangent is the one that's increasing. Cotangent's the one that's decreasing or going down. So in order to find dx dt, I have to take this derivative with respect to time, not x. What's the derivative of y? 1 what? dy dt. What's the derivative of cotangent? Good. Some of you are starting to memorize that. Negative cosecant squared x. And then what do I have to put after it? dx dt. And that's because I'm not taking the derivative with respect to x. It's with respect to time. So now I have to plug in 3 for my dx dt. So 3 in for this. And I have to do the cosecant of my x value. So I have to do the cosecant of pi over 3. I have to square it, and then I have to do the negative of it. Well, pi over 3 is 60 degrees. If you need to, draw a little picture. Here's 60 degrees. That's radical 3, 1, and 2. What's the cosecant? 2 over radical 3. And then what do we have to do with 2 over radical 3? Square it. What's 2 over radical 3 squared? 4/3. So I'm going to have negative 4/3 times 3. And so that's going to give me that dy dt is going to be negative 4, look at your units, centimeters per second. So I want you to look at this one for a minute. Pi over 3, this is pi, this is 0. So right here is about pi over 3. Can you see how dx dt is moving in the positive direction because this is positive? And can you see why y would be going in the negative direction when x is going in the positive direction for this function? That should make sense. All right, so now we want to know what about at 3 pi over 4? That'd be right about here. So it wants us to find the change in y with respect to time. So we're going to take our dy dt again. Negative the cosecant, this time of 3 pi over 4, and we're going to have to square that, times dx dt. All right, so the cosecant of 3 pi over 4. What is 3 pi over 4? What's pi? 180, right? What's 180 divided by 4? 45 times 3. Add 45. 45 and 45 is 90, plus another 45 is 135, right? So I'm at 135 degrees. That's right here. This is negative 1, 1, and radical 2. So what's the cosecant of 3 pi over 4? Just radical 2, right? Because cosecants are over y. So if I do that, I get radical 2. Then if we square it, what is it? 2. So it's going to be negative 2. And then dx dt is 3. So we're trying to find dy dt. And so that's going to be negative 6 centimeters per second. So right here at 3 pi over 4, if x is moving at 3 centimeters per second, y is changing at negative 6 centimeters per second. And that's because it's steeper here than it was there. So x is still at the same rate, but y is changing more quickly there because it's a steeper curve at that point. Okay? Make sense? Any questions? All right, so you guys are doing something different than what's on your assignment sheet. This is all correct on Canvas. If you want to look there, it's page 149, numbers 1 through 8. That's section 3.6, 2.6 rather.